Welcome to this report on the energy use in the Bitcoin network. I'm excited to be presenting this today because this has been about 6 months in the making and has required analysis of 42 different Bitcoin mining companies and quite a bit of data crunching and field research. We're at an important inflection point in history where big policy decisions have been made about Bitcoin right now, and so it's more important than ever that these policy decisions are anchored on really robust data. To cut to the chase, the data that they are relying on comes from, to a large extent, the Cambridge Centre for Alternative Finance. And in this report, what I'm going to be showing is how that data set is incomplete and how, because it's incomplete, it may lead us to some very wrong conclusions. To give some context, first of all, this is not the first time that people have questioned whether a technology should be curtailed in its use or encouraged. People tend to forget that this happened with the solar industry as well. Here's an article from The Atlantic in 2016, where for the first time it was acknowledged, yes, the solar industry has paid off its carbon debt. In fact, it had paid it off at that time 5 years ago. Here's the interesting thing. The solar industry in its modern form was around since 1975. It took 36 years to pay off that debt. The Bitcoin network, by contrast, has been around since 2009. It is my contention from my analysis that by the end of 2024, it will have paid off its carbon debt, which is 16 years and less than half the time it took the photovoltaic industry. Let's leave that as a placeholder to revisit later and come back to the Cambridge report. The finding is that 62.4% is coming from fossil fuels. Now, if you look at the people who have picked up this study, there's a number of them. Here's one. This is from Earth Justice, where they say, yes, fossil fuels accounts for nearly 2/3 of Bitcoin's mining total electricity mix. Here's another report here entitled Crypto is Killing the Planet, where they say exactly the same thing. In fact, it's cut and paste from the previous article. Fossil fuels is accounting for nearly 2/3 of the Bitcoin mining's total electricity mix. Here's a third article from Greenpeace USA. Same thing again, accounting for almost 2/3 of the total electricity mix. So it's all coming from the same study here with that 62.4%. In other words, 37.6% coming from zero emission sources. Okay, so we can see how this very quickly becomes politically charged, how it gets picked up by environmental movements. It also gets picked up by the mainstream media. Here's a few here. And the other point they've picked up is the study seems to be showing that it's trending in the wrong direction. So we were forgiving to solar because it was trending in the right direction the whole time along. But if the industry seems to be trending dirtier, then the voices and the critics will become louder. So the trend line is really important. So here's 3 mainstream news reports. Bitcoin mining's getting even more polluting from Bloomberg. New York Times, now mining is even dirtier since the China ban. Here's one from CNN. Bitcoin is getting dirtier. You can see the general narrative here. Okay, so enough narrative. Let's look at the data. So here we have a comprehensive model that I've been building for a little while now. And here we're going to have a starting point, which I've replicated the Cambridge data. So they came up with 37.6%. I've come up with 37.5%. So this is replicating their publicly disclosed methodology. So what they do is they look at where Bitcoin mining occurs in the world. They have very good methodology for working out the IP addresses, where it's occurring. They look at the grid mix within that country, which is what I've done as well. Now, there we are, all the different grid mixes of different countries around the world. And based on that, they've come up with an estimate of on-grid Bitcoin mining. Now, to their credit, they state the limitations of the model. And here they say, our estimates do not account for any activities that could reasonably be expected to reduce emissions, such as using flared gas or off-grid, behind the meter. However, what's happened in the last 2 years has been that a substantial portion of Bitcoin mining has moved off-grid. And why is that? Well, it's for a very simple economic reason. As the Bitcoin price has gone down, it's simply not economical to be mining based on wholesale electricity prices. So increasingly, people are forming direct power purchase agreements with off-grid suppliers. Now, I have been in communication in one way or another with 10 people using flared gas as a source, 20 people using renewable energy, and also looking at 12 publicly listed or large companies which use a mix of grid, fossil fuel, and renewable. So a total of 42 miners. And what I've done here is I've used that Cambridge base, and we're going to see what happens once we factor them into the model. So here we have the largest renewable-based miners, including ones that are predominantly but not exclusively renewable. So watch this figure here, 37.49%. What happens as we gradually include each of these different Bitcoin renewable energy users. So step one is we're going to use this data source here. You can check my paper where I describe the methodology that I've used to gather this data. But in a nutshell, it's all using publicly accessible data. Almost all of these companies here are publicly traded companies, which means they have to disclose records. Here's an example here of one from a finding from Hut 8, where they have to disclose the amount of megawatts and also the hash rate. And so we go through and do that consistently. We start to get a overall picture pretty soon of what the off-grid component is. So we're going to firstly put in these renewable miners. Already we can see that's gone up substantially. Okay. So now, secondly, we're going to factor in the large US and public miners which are using off-grid. We're going to factor in Stronghold, which is a miner which is using coal tailings. Now, whilst that provides some advantages to the local environment, it is using a fossil fuel base. So in terms of this model, that counts as 100% fossil fuel. We're going to factor in the long tail of some smaller providers of renewable energy. There's 3 of them. Okay, so already we're starting to see this model change quite a lot. Finally, we're going to add in the people who are using curtailed hydro energy in China. Now we're almost at 50%. Next, we're going to look at the fact that in the Cambridge model here, you note that it only goes up to January 22. And this matters because what happened after that was that there were a lot of Kazakhstani miners who were shut down. Here's one estimate at 202 megawatts that was shut down. Here's a secondary estimate which says that it was actually probably a lot higher at 600. Whenever there's 2 different data sources, I've always gone for the more conservative figure. And we can calculate what that means to the hash rate of that country. And conservatively, we can assume that it's gone down to at least 9.6, probably substantially less, probably more like 4. But again, we're going to be on the safe side here. Okay, so now it's over 50. And finally, we're going to use a study which I did and published a couple of months ago, which looked at the carbon negative mining that was occurring across the grid. Came up with the total number of megawatts and also came up with the percentage of overall hash rate. So this is available on batcoins.com. We add that figure in here, which is off-grid flare. Now we get a very different figure, don't we? So 52.2. So this is optimized for statistical robustness. So the reason this is lower than the Bitcoin Mining Council's estimate of 59.4 is that I've used some conservative assumptions wherever possible. Even though we know strongly that the Kazakhstan hash rate is probably substantially less, and that within China, it's highly unlikely that most of the network is on-grid. It's most likely that most of it is using curtailed hydro energy. The very minimum that the complete Bitcoin network is using right now is 52.2%, zero emission. So this has gone up since 2021. So that's the first point. It is not getting dirtier, it is increasing. Let's look now at the overall picture and why there's a difference between the Cambridge study and this one. Well, it's very simple. The Cambridge study is measuring 47.2% of all Bitcoin mining. However, 52.8% of it is off-grid. And when we factor those two things in together, this is the picture we get of the complete network. This changes everything. It means that these headlines about it getting dirtier are based on an incomplete data set. It means that these sources here, which are saying that 2/3 of the network is fossil fuel, is incomplete. It's actually less than half. So that's incorrect. This is incorrect. This copy and paste is also incorrect. The other important thing here is that there's this figure that gets quoted a lot saying that coal is the largest energy source of the Bitcoin network, accounting for 36.6% of it. Now, that's also incorrect because, again, that's only measuring the on-grid portion. And there's a really important point here, which is that ultimately what the Cambridge study is measuring is not so much Bitcoin mining, but what happens on-grid. And I've got another chart here, which shows this comes from Our World in Data. This is the global grid mix. So if you're using electricity on average somewhere in the world, every time you plug something into a power point, whether it's charging your cell phone, turning on a light, charging your electric toothbrush, you are using as a predominant source coal, 36.7%. So the study is not so much measuring Bitcoin as it is measuring the global state of electricity. The interesting thing is that because Bitcoin, unlike other industries, is able to use more than half of the network off-grid, it is one of the very few industries in the world which does not have coal as its major source of electricity, and it is one of the very few industries in the world which is more than half zero emission based. So in summary, coal is not the number one energy source of Bitcoin. Number two, it is trending more clean, not more dirty. And number three, over time, models lose their tune. Cambridge has acknowledged this itself, to its credit, and are in the process of building in the data which they've currently left out. However, like all academic institutes, these things take time. In the meantime, it's important that we regard the Cambridge study as not a complete statement about the Bitcoin mining network, but only the on-grid portion. If you've got any questions or queries on this, would love to hear them. As I say, this has taken a little while to build now. My own personal impression of this model is that the true state of the network is more like 59%, which is very close, incidentally, to the Bitcoin Mining Council's data. This model is using the Cambridge model and then augmenting it with publicly accessible data, so we can be very confident in the robustness of the data and that the actual figure is definitely not less than that for zero emissions and is possibly significantly more than that.